Good afternoon, everyone. My name is Dominic Preuss, and I'm very excited to be here at Google I/O. So welcome to everyone who made it this far in the conference, and everyone that's on the live stream. First of all, you made it to the last session of the last day, so round of applause to everyone who's still here. We're very excited to talk about Cloud Spanner. Before we get started, I want to set your expectations. So before we do the session, I want to tell you what we're going to do, and if there are other sessions you want to go to, I won't be offended, but I want you to know what to expect. So in this session, we're going to talk about a brief history of Spanner at Google. I'm going to give you an explanation of what Cloud Spanner is, and then we'll do a demo. And hopefully we'll have a few minutes left at the end to do some question and answer. So why did we build Cloud Spanner? So you have to go back to 2005. Every dollar that Google made in its advertising system called AdWords was built on the back of a manually sharded MySQL cluster. We were sharding by customer IDs, and we had to move a customer. They had outgrown the shard, and we needed to move them to another shard. That last reshard took multiple years to complete. And when we did that, we decided we had to have a better way. How many people in the room have either a manually sharded MySQL or a manually sharded Postgres implementation? All right, so those of you in the room know the pain that we felt. So it was at that point that we decided we needed to do something different. So what were Google's needs? We needed a horizontally scaling database that we could give our most mission-critical data to. So we needed ACID transactions with global consistency. AdWords was already a global product at that point. And we needed no downtime. Every minute that we were down cost us millions of dollars of revenue. So how were we going to solve this problem? So the answer was Spanner. So what is Cloud Spanner? We're going to start by taking you through a quick video as an overview of what the product is.
We demand a lot of our databases, and our databases demand a lot of us. They're fragile, expensive, and tough to maintain. When things break, it can be hard to put the pieces back together at the speed of your business, and you often lose data in the process. We've all come to expect that distributed databases can't be globally consistent and scalable. But what if you didn't have to make trade-offs? What if you could have a fully managed database service that's consistent, scales horizontally across data centers, and speaks SQL? This is Cloud Spanner, a mission-critical relational database service built from the ground up and battle-tested at Google for strong consistency and high availability at global scale. At Google, we use Spanner for services that billions of people access every day. It's the only cloud service designed to be a massively distributed relational database with transactions and SQL semantics. And we're talking massive. Spanner can scale up to millions of machines across hundreds of data centers and trillions of database rows, stretching across the globe while behaving like it's all in one place, where you want it. We've built Cloud Spanner to be fully managed and secure. Automatic sharding and synchronous replication with low latency and schema updates without downtime means your data is highly available and reliable. Instead of endless provisioning and worrying about maintenance, you can focus on growing your business. No matter your needs, you don't have to hit a wall with your database service. Get started with Cloud Spanner and build what's next.
Great, so Cloud Spanner is the externalization of that technology that we started building in 2005. So in 2005, we started building Spanner. It went into production to power the AdWords system in 2007. And over the last 9+ years, many of Google's mission-critical applications run on Spanner. Cloud Spanner is the Google Cloud Platform service that we have exposed to give outside developers access to the same powerful tools that we have inside of Google for their mission-critical applications. So Cloud Spanner is a fully managed database service with global scale. So what this means is you come in, you create an instance, You put data in the system, and that's all you worry about. We do backups, we do upgrades, security patches, and making sure that your data is always protected and secure. The second thing was it's a traditional relational database. So it gives you relational semantics. So you have rows and tables and schemas, as well as the transactional capabilities. You have active transactions across as many rows as you want. You can update hundreds or millions of rows in a single transaction, and you get to use SQL. So we do all of our SQL definition in SQL, and we do all of our queries in SQL. It's ANSI 2011 SQL with extensions, so it's been built to be as compatible as it can be with your existing relational database technologies. We do automatic synchronous replication within and across regions for availability. So one of the things that is inherently different about Google Cloud Platform versus other public clouds is that we work off the assumption that we have to be multi-regional to reach the level of availability necessary to run our business. So Google Cloud Storage is inherently multi-regional, Cloud Data Store is multi-regional, and Cloud Spanner is designed to run multi-regional. It's also been battle tested inside of Google. So we say here 5 years for things like AdWords in the Google Play Store, but it's been now over 9 years that we've been building applications and running all of Google's mission-critical applications on Spanner. So the question is, so what? You've said a bunch of words, you've said a bunch of things, database terms. What does that actually mean? So what Cloud Spanner allows you to do is have the horizontal scalability of a NoSQL solution with the relational and transactional characteristics of a relational database. So what this means is when you come across a problem, a business problem that requires a solution, you have an answer. We see this pattern time and time again with both our large enterprise customers and our cloud-native companies, where they build a project or a solution or a technology on top of the database that they know. It might be MySQL, it might be Postgres, SQL Server, whatever it happens to be. And then if that project becomes very successful, it gets popular and they have scalability issues. So now they have to worry about things like read replicas to scale reads and continue to scale out their solution. And at some point, they basically outgrow that technology. So if you've outgrown your relational database technology, your one immutable requirement is horizontal scalability. So then this takes you into things like Cassandra and MySQL and those eventually consistent technologies that give you the horizontal scalability, but then you have to re-architect your application to understand those consistency requirements. Cloud Spanner allows you to scale out your application without compromises around transactional semantics or your relational structures. So if you compare this to a traditional relational database, Cloud SQL has schemas, SQL, strong consistency. We don't have failover because we don't do master-slave. We use a custom Paxos consensus algorithm and two-phase commits so that we don't have master-slave. We have consistent versions of the data in all the replicas, so we can serve your data out of whichever replica is most expedient. Instead of vertical scaling by creating bigger VMs, where you're limited to the largest VM that you can get from a public cloud provider, we scale horizontally. And then also replication, it's not configurable, it's something you get automatically. Now, how does this compare to your NoSQL solutions? So NoSQL solutions, no schemas, limited SQL or NoSQL, eventual consistency. You can get high availability because you have a distributed system because you can scale horizontally, but you still have to worry about configuring your replication. So Spanner allows you to have the best of both worlds in a single solution. One of the biggest questions that I get is, you've had Spanner internally for 9 years. Why was it so hard to bring it to the outside world? We worked on it for years, and it was in early access for over a year. And it's because we really wanted to package Spanner in such a way that it was open standards, and it met our enterprise customers where they are. Google is tremendously committed to the idea of being the open cloud. So we wanted to adopt any open standards that we could to really make sure that it was as easy as possible to adopt this technology. So we use standard SQL, which is ANSI 2011 with extensions. We do extensions for things like interleave tables and some of the things that are specific to Spanner. For our enterprise customers, out of the box, you get encryption at rest. You get audit logging, so you can know who's making changes to your database. And integration with Google Cloud Platform's identity and access management. So you get role-based access patterns to all of your data. So if you're a large enterprise company that's trying to move your mission-critical data onto Google Cloud Platform and Cloud Spanner, these are things that you need to know that you've achieved the solution that you need. We've also got open source client libraries for all the popular languages. We talk a lot about being a developer-friendly platform, and for us that means really strong documentation and really great client libraries. So we launched our beta with Java, Python, Go, and Node. And just today we launched our PHP clients, and we've got Ruby and C# client libraries coming shortly. The last thing we did was we developed a JDBC driver. So we have a read-only JDBC driver specifically for our partner ecosystem. So partners are tremendously important to Google's success for the Google Cloud Platform. So by providing this JDBC driver, we made it as easy as possible for both our partners, like Tableau and Looker and MicroStrategy, the BI tools, as well as customers to integrate it into their workloads. So we provide this read-only JDBC driver to make it easy as possible to get the data out of the system. During the early access program and now from beta to general availability, we've seen a lot of traction on specific types of workloads. And these workloads are actually very similar to what we've seen inside Google. So the first one is transactional. If you have a heavily transactional workload where you need global consistency, Cloud Spanner is an ideal solution. So examples of this are financial services. If you're moving around money, you need to have consistent data. If you are doing inventory management or supply chain applications, you can't sell more inventory than you have. So it's important that you have a strongly consistent data store to store your inventory. Another good example of this is ad tech. So ad tech, money, budgets, you're serving ads against a budget. You can't spend more than the budget of the customer. So it's very important that you have a consistent database for those types of systems. The next one is scale out. And so the type of customer that we actually is the easiest to understand Cloud Spanner are those that have these manually sharded MySQL and Postgres databases. If your database has gotten large enough that you are manually sharding your database, either at the application layer using some sort of sharding technology, then you understand the need for having a horizontally scalable database. The fact that you can pick a single database and never have to worry about outgrowing it, up to petabytes of data, is something that's very reassuring when you're choosing an architectural solution to build your applications on. The third one is global data plane. So an interesting fact is that Google Cloud Platforms, all of its control planes are based on Spanner. And so if you have to have a consistent view of your systems for control plane or things like user accounts, we see this as a really common use case for Cloud Spanner. If your customers happen to be globally distributed, let's say that you're a US company that has a lot of customers in Japan, or a European company that has a lot of customers in the US, then having a globally distributed single source of truth system for things like user accounts and metadata around your system is very valuable. The last one is consolidation, and this is actually one that I'm most excited about. As a former CTO of a company, we had multiple solutions. We had a Postgres database for our customer data, we had a Mongo database for our logging data, and we had an analytics solution for all of our logging data. And so what's great about Cloud Spanner is it allows you to consolidate all your data stores into a single one. So if you had a Postgres cluster for your user data and a Cassandra cluster for all of your logging data, you can now bring those into a single scalable data source that is globally consistent with a single source of truth to run your applications. And this really starts to give you much greater velocity from a developer perspective. You don't have to worry about ETLing the data or trying to do joins across disparate data sets. You have a single source for all of your data, so you can do real-time, consistent queries on the data. So how does Spanner work? So the atomic unit for Cloud Spanner is an instance. So when you create a Cloud Spanner instance, you are selecting two things: a instance configuration, which is effectively the replication topology of the database, and the number of nodes. The nodes are the compute units by which you can do work on the database. So once I have that data, I have created my instance. If you're creating a regional instance, which we have today, and we'll have multi-regional instances rolling out later this year, for a regional instance, you're going to have 3 replicas in 3 different zones in a single region. And then when you create a database inside of that instance, so your database is your logical separation of your data, all of that data is going to be available and copied and replicated across all of your various replicas. So what this does is gives you a fault-tolerant, highly available system that has your data separated across multiple zones. So what happens is when an update comes into the system, you don't address a single replica. You don't address a cluster. You just address your instance. So whether or not you're doing a write from a virtual machine in Europe or the United States, you just say, hey, Cloud Spanner, here's some data. We will automatically route that data to the nearest replica that can serve your request. It'll come into one of the replicas. The commit will be figured out using our Paxos algorithm and our two-phase commits, and then we'll get consensus from the other replicas to write that data. All of that is completely transparent to you, and when you're writing data to Cloud Spanner, it looks just like a single node database. There's nothing about the behavior that you will see that will look any different than if you were addressing an individual single node database like MySQL or Postgres. In terms of what this does in terms of latency, is when you're doing reads, you're talking about single millisecond reads, and you're talking about sub 50 millisecond writes. So depending on the shape of your data and how fast you're writing data and reading data, you're going to see very similar performance than you would see out of a single node machine, but you're getting the distributed nature of Cloud Spanner. Well, how does Spanner achieve this? There has to be some trade-offs. So one of the things that's really interesting is how we actually structure the data. So if you are using a traditional database, traditional relational database, your data is going to look like this. You're going to have a single table. In this case, our example is Singer ID. We've got ID 1, 2, 3. And then you're going to have an album table that's going to have its own ID, so album ID. And you might have a foreign key constraint here, but you basically have two disparate tables and you're doing joins. Spanner, to be performant and to support the relational semantics in a distributed system, has the idea of interleave tables. So the way that Spanner does this is we allow you to tell us what is the physical relationship of your data. An interleave table is effectively a child table that allows you to create a connection of the data so that we can group it together. You're telling Spanner that this data, which is albums, is closely related to Singer. So what that allows us to do is to make sure that we keep that data close and we can quickly serve data that is within a single parent, so in this case, Beatles. This also is how we implement foreign key constraints. So if you want to do things like cascade on delete, then you basically have all the child table has all the same keys as the primary, as its parent, and then you can say cascade on delete. So when I delete a child row, then, or a parent row, you can cascade on delete to make sure that you maintain that integrity. We don't do foreign key constraints across these top-level tables, which we call root tables, because then that would affect our performance. And so by creating this interleave table, we're able to give the performance that you need, but structuring the data in a slightly different way. So what does that look like when I build my schemas? So this is how you do DDLs, so when you define your schemas. So you can say, create table singers with Singer ID and Singer name, and the primary key is Singer ID. So we use primary keys that are actual data. So we encourage you to create a great enough separation in keys as to use actual data from your system as the primary keys. So now if we wanted to create a child table or an interleave table, we would say create table albums. You can see that it has Singer ID as a key, as a property, because we need to have all of the same ones as the parent. We've added album ID as a separate ID, and we've added album name. So we said the primary keys need to be Singer ID and album ID. And again, this is so that we can interleave the data together. And then we say interleave and singers. So what this means is whenever you create a child row of the parent table, that data will be physically located on the same nodes in Cloud Spanner so that we can quickly do queries across that data. Some people like to think of this as a pre-computed join. So it allows you to basically, by laying the data out on disk, and in the relational semantics, it allows us to do these pre-commuted joins. The other thing it allows us to do is no downtime migrations. So if you wanted to do, say, alter table singers and add column age, that is a no downtime migration. So we don't lock the database, we don't lock the tables. Spanner does cell-level pessimistic locking, and so you can do online schema migrations without bringing down your system. These were all things that we had to develop to be able to run Google's business. It's our mission-critical applications at the scale and speed that we needed. So what does this look like in code? So I talked a little bit about the importance of documentation. I'll also talk about the importance of our client libraries. I'm a Python guy, so we're going to go through the Python experience. But we spent a lot of time with our Google Cloud client libraries to make sure that it's as easy as possible to get up and running. So for Python, by the way, how many Python people are in the room? Fantastic. You're my people. First thing I'm going to do is import Spanner from google.cloud. So I've imported the package necessary to get access. I'm going to instantiate a client. So a client is a pool of connections. So you create a single client for your application, and then the client libraries in the background do all the connection pooling to optimize your network traffic back and forth. I'm then going to say grab a handle to my instance. So my instance ID is a string. I'll pass that to the client, say grab my instance, and now I need to handle the database. So you can have many databases per instance. Again, this is a logical separation of data. I'm going to say my database ID is my database ID, and then I'm going to grab a handle to my database, and now I can start to run queries. So in 7 lines of code, I'm able to start executing queries, and then I can start printing out that data. As a quick high level, how does Cloud Spanner fit into the overall portfolio? So if you look at our portfolio of products, going from right to left, we start with a in-memory data store. So we provide Memcache as part of App Engine. This is obviously very good for web and mobile apps and for caches. Cloud SQL is our managed relational database service. So today it supports MySQL and Postgres. We were very excited to announce Postgres support at Cloud Next in March. Skipping over Cloud Spanner, Cloud Data Store. Cloud Data Store is our document database for mobile and web applications. This is what powers things like Snapchat, Pokemon Go, and other large gaming applications. Cloud Bigtable is our analytics database. So this is for high throughput, low latency writes. So if you need single millisecond reads and writes of very large amounts of data, Cloud Bigtable is what allows you to do that. It's fantastic for time series data or monitoring data or anything that you need to do those very heavy writes and then do really fast table scans. Cloud storage, which is our object store, I'd like to keep it in here because we're seeing more and more people that are writing their data into GCS or into Google Cloud Storage as its data store in things like Avro and Parquet and JSON files and log files, and then running federated queries from BigQuery across that data. So we see a number of people that are starting to use it as a column data store by putting those files directly into a object store bucket. And the last one is BigQuery, which is our cloud native warehouse. So this is a federated query engine that allows you to search across the data in BigQuery, Google Cloud Storage, Google Drive, and we recently announced the ability to query data in Cloud Bigtable as well. So that allows you to do joins across data in multiple data sources, and doing it all from a single interface using SQL. So when you come back to Cloud Spanner, what is it good for? So if you have an application that doesn't have one of 3 requirements, then normally using MySQL and Postgres is great. Great ecosystem, lots of tools, but there are 3 things that will drive you to Cloud Spanner. If you need super high availability, so you either need 4 nines of availability for a regional instance or 5 nines of availability for a multi-regional, then Cloud Spanner is a solution for you. You don't have to worry about scheduled downtime because there isn't any. We aren't doing, when we do binary upgrades, you don't see it. It happens online. It doesn't have any impact to customers. 5 nines of availability is 20-some seconds a month of downtime. And so it allows you to run your mission-critical applications. So number 1 is super high availability. Number 2 is if you need more writes than you can put through a single node. So if you're doing lots and lots of writes on your MySQL or Postgres database, you can shard the reads by creating read replicas and pushing your read traffic to read replicas. But if you're doing more writes than you can put through a single VM, then you can only scale vertically to as large as the biggest VM is on that platform. So Cloud Spanner allows you to go beyond that by doing as many writes as you want by just adding more nodes. The last one is data. So if you have more data than you can reasonably put into a relational database, and that's somewhere around 3 terabytes, and you need to be able to scale up to tens or hundreds or even petabytes of data, Cloud Spanner allows you to scale beyond the storage requirements of a traditional relational database. So that's where people get moved from Cloud Spanner into, or from Cloud SQL into Cloud Spanner, is when you have one of those 3 requirements that can't be met by a traditional relational database. One note, when I did this slide last week, Cloud Spanner was still in beta. We actually went to general availability on Tuesday, so it is now generally available for everyone. It is no longer a beta. Great. You've just talked about a bunch of databases. Which one do I use when? So this is something that I put together recently that I always like to show in any database talk is how do I choose which solution to use? So we'll start at the top and work our way down. So first, is your data structured, yes or no? So if the answer is no, then you're going to end up over in one of our unstructured object stores. So if you need mobile SDKs, then you're going to use Firebase storage. So for those of you who don't know, as you've gotten through this conference, Firebase is our mobile developer platform, and is the primary way that mobile developers access Google Cloud Platform services. So if you need a mobile SDK, you'll go to Firebase storage. If you don't, then you'll go to cloud storage. All of the data ends up in the same place, but it's just 2 different developer experiences. If your data is structured, then are you doing an analytics workload? If you're doing an analytics workload, then you're going to end up over on the right side. And then your question is going to be, do you need lots and lots of updates or super low latency? So if the answer is yes, you'll end up in Cloud Bigtable. So we recently did an experiment with a large financial services company where we're doing millions and millions of writes a second into Cloud Bigtable, and we're talking about sub 10 millisecond reads and writes. That's Cloud Bigtable. If you don't need lots of updates and you're looking at more of an append-only workload or a traditional data warehouse, then you're going to end up over in BigQuery, where you're talking about single-second queries for doing massive aggregations over lots and lots of data. If your data isn't analytics, then you're going to end up in the middle here. And then the question is your data relational? Without getting into a whole religious conversation about SQL versus NoSQL, the real question is your data relational? Do you have lots of references and are doing lots of joins across multiple tables? Then this will drive you into one of 2 solutions. So if your data is not relational, then the question again is, do you need mobile SDKs? If the answer is no, you're going to end up in Cloud Data Store, which is our scalable document database for web and mobile applications. If you do want mobile applications, and you want the native mobile SDKs, then you're going to end up in Firebase Real-Time Database. If your data is relational, then you're going to be over on the left side of our slide. And so then the question is, do you need horizontal scalability? If you don't, then generally MySQL and Postgres are going to provide you a great experience. They've got a much more robust ecosystem, open source tools, lots of support for you getting up and running, and takes away some of the complexity of doing the work that you need to do. But if you do have one of those 3 needs, which is super high availability, more writes than you can put through a single VM, or more data than you can fit into a single relational database, then you're going to end up in Cloud Spanner. I talked a little bit before about how important it was for Google Cloud Platform and Cloud Spanner to have a robust partner ecosystem. So we spent a lot of time during the early access program and since launch in engaging with our partners to make sure that whatever tool you happen to be using today, you can continue to use with Cloud Spanner. So I'm very excited that we have support from companies like Expleni, Looker, MicroStrategy, and we're going to continue to see integrations roll out the rest of the year from Informatica, Tableau, and all of our various partners. And so if you happen to be an Illuma user today and you want to be able to migrate your data into Cloud Spanner, we're making sure that we have those integrations in place with those partners so that you can use the tools that you're used to using, and Cloud Spanner will just fit right into your existing architecture. Great. So now we're going to do a demo. So before you switch over to the machine, any good talk has a demo. Go ahead and switch. Yep. Great. So I'm in the Google Cloud Console, and when you log in, we provide you a bunch of graphical tools to help you understand. So we're in the next spanner. So if you saw any of the spanner talks, you've seen the demo. It's been running over in the pavilion. This is a globally replicated Cloud Spanner instance. So what this means is we have data in the United States, Europe, and Asia. So Iowa, Oklahoma, Belgium, and Taiwan. We've got 50 nodes of capacity. And so what this means is we can do about 500,000 reads a second and about 100,000 writes a second. So you get about 10,000 reads and 2,000 writes per node. You can see CPU utilization and the type of data. We've got about 17 terabytes of data that we're running. We provide you some monitoring tools, so you can see what we've been doing over the last 7 days. Going back, you can see we were loading some data, running a bunch of demos. You can see the operational work through. You can see how much data we've been writing, and you can see that we've been scaling up to about 18 terabytes of data. So we provide all these tools as part of the product. If we want to then go ahead and look at a database, so again, multiple databases inside of a instance, you can see here all of our tables. So we can look at the account table, we can see the schema, we can see indexes. So under event, we can see we've got indexes. If I want to preview the data, I can. So we're going to look at the venue info table. And if we want to preview it, we can look and say, OK, these are the venue IDs, venue names, and country codes. If I want to introspect my data and take a look, I can go ahead and write a query. I'm going to cheat and cut and paste because I'm a terrible typer when people are watching me. It's the end of the conference. I really want to be on the beach, so let's look for any venues that have beach in the title. We'll run the query, 43 milliseconds to query across 18 terabytes of data in 3 continents and 5 different regions. And as one of my colleagues likes to say, what's so remarkable about this query is how unremarkable it is, right? Select venue ID, venue name, country code from venue, where venue name contains beach, right? This is standard ANSI 2011 SQL. There's nothing special about this at all. If I want to see what that query looked like, we provide a query explain, so you can look at the data and say, OK, we did a distributed union. We get down to the end, we say, oh, there's a table scan. That's probably bad. I should probably add an index for this type of query and add a secondary index to make these queries even faster. So we can get that 43 milliseconds down to 10 milliseconds. Talked a little bit about the developer experience. So again, I'm a Python developer. So I'm in Cloud Shell. So for those of you who don't know, if you click this little button up here in the corner, that actually spins up a VM in your project and instantiates a SSH session into the VM, which allows you to basically have command line access to all of your VMs. So if I'm getting ready to run this, the first thing I'm going to do is say, OK, I need the client library. So I apologize for using sudo. It's bad hygiene, but this is a demo. Google Cloud Spanner. Right, so I'm going to check and make sure I have all my dependencies. Great, I've got it installed. Let's go ahead and start a command line, interactive command line. Great. So going back and doing that code that we did before, first thing I'm going to do is grab my import. I'm going to import my package. I'm going to grab my client. So this client is created. It's using credentials based on the fact that I've done gcloud, so it knows where to find the credentials in my JSON file with my credentials. Great, I've got a client, and I need to grab a handle to my instance. Got an instance. I need a database. Give me a handle to my database. Obviously, we could do this all in one line of code. And now I'm going to run a query. Great. So again, what I've done is I've selected venues. We just did a talk in Cloud Next in Tel Aviv, so I wanted all the venues that were in Jerusalem. I can then print this out and say, for row in results, print row. And these are the results. So 7 lines of code. I've run a query over 18 terabytes of data, returned them, and printed them out to the command line. That's all it takes to get started on Cloud Spanner. And we spent a lot of time really optimizing this to make sure that it feels idiomatic for Python and idiomatic for all the client libraries. So it's very clean to use. The last thing I'll show you is that we actually export all of our data into Stackdriver. So for those of you who don't know, Stackdriver is our multi-cloud monitoring system. It provides logging and monitoring. You can push metrics. So we've pushed all of these metrics into Stackdriver, which allows you to build custom dashboards. So this is our ticker sales demo. So we can see spanner utilization over time, throughput to the database. Let's do a week. We can see the number of nodes we have, the size of the demo database. And because the data is in Stackdriver, you can set up custom alerts. So custom alerting policies that can either send you emails, text messages, integration with things like PagerDuty, whatever happens to be for your monitoring system. Because all the data is available in Stackdriver, you can set up whatever type of custom alerting and monitoring you want to do. So Cloud Spanner really from the beginning was integrated with all the various parts of Google Cloud Platform to make it as easy and seamless for people to get up and running. And so these are just some examples, along with things like identity and access management and the way that we do our audit logging, so that all of it just works out of the box.